The presentation today will consist of two parts. First, I'll do presentation about the AnyLogistix. I know that some of you already know AnyLogistix and know what it is, but also there are still a number of people who do not know what is that and what are the ideas behind that. So I'll do a brief introduction presentation, and then Anatoly will demo you the product. So when you design your supply chain, there are a lot of questions you have to answer. This is where to locate the facilities, what are the inventory policies or sourcing policies you have to use, what is the risk associated with your supply chain, is there any possibility of the bullwhip effect in your supply chain, what if you change something in your supply chain, how it will affect its efficiency. So there are a lot of questions you have to answer when you design and analyze your supply chain. And if we try to map the supply chain problems to the level of abstraction, to the level of details which are needed to solve this problem, we will get the following picture. If you take into account things like locations, flows, or we represent our supply chain as a set of flows, we assume that all the dependencies are linear and the behavior is continuous, then that level of details allows us to solve problems like network optimization and greenfield analysis, where to locate the facilities. It allows to do a master planning and do some, well, this is quite simple, fleet size estimations. Then, if we add the details into the model, like the dynamics, randomness, network level logic, processes, resources, then we may address more problems, like how to do the transportation within our supply chain, what should be the inventory policies and sourcing policies. Also, all the metrics which are related to time becomes measurable. This is like the capacity, service level, bullwhip effect. Also, you can do risk analysis, because of risk actually always assumes taking into account time and randomness. To do risk analysis in supply chain without time and randomness just doesn't make a lot of sense. So, and then if you want to go even deeper, adding how your supply chain objects works inside for walls, let's say how your factory works, how many production lines you have, how your warehouse operates inside, how your transportation system works. It allows you to address even more problems. So you may actually estimate how this inside logic influence your supply chain, your overall supply chain. How your, let's say, production planning, again, influence the supply chain KPIs. So the more details you take into account, the more problems you may address. And if we try to represent that on this chart, we'll get the picture like that. Basically, it means that on the top of this pyramid, there are problems which doesn't require a lot of details to be solved, but there is a very limited set of those problems. And then the more details you are able to add to the model, the more problems you can address. If we look at the methods which are commonly used to address supply chain, first of them, that's only spreadsheets or Excel, but certainly it allows you to solve only quite a simple supply chain problems. There is, and the more oftenly used methods for the supply chain optimization, design and analysis are analytical optimization and dynamic simulation. I'll talk about them a bit more on the next slides. If we consider analytical methods, so they allow to do network optimization, which is about where to locate your facilities, what are the product flows between the facilities, and what is the throughput of those facilities. Please don't confuse throughput and capacity. That's different things. Then you can also do master planning. Basically, it means that you may calculate your inventory at the beginning of the period, at the end of the period, and you also know how much goods you have to ship within the period or you will get within the period. And actually, in the analytical model, nothing happens within this period. You have just the beginning and the end, nothing else. And also it allows to solve some transportation problems, for example, fleet size estimations. And if you try to generalize that, so with the analytical methods, you answer the question, what's the plan? What you have to do? And when we are talking about analytical methods, we have to take into account that, we have to remember that analytical optimization may handle a large-scale problems. And this is a significant advantage of analytical optimization over dynamic simulation. But at the same time, analytical model is not able to describe the reality of the supply chain. You always have to do simplifications to be able to map your supply chain to this analytical world. For example, one of the simplifications you have to do when you use flows, you assume that they're uniformly distributed within the period. Let's say you have that analytical model says that you will receive 300 units of something to your warehouse per period. And let's say this period is 1 month. Basically, it means, from this analytical point of view, that you will receive 10 units each day. And we know this is not it's not the real picture, because in the reality you have a lead time, you have vehicles, you have the capacity of the vehicles, many things which actually influence of how many goods you receive each day within the period. Also, there is no way to take into account things like randomness, supply chain operating logic, and time, or dynamics, how this supply chain actually behaves in time. And we also have to understand that this approach is like black box, because of when you work with a tool where you just feed the data, and then this tool creates this system of equations, and then use the solver to solve this system of equations. You have no idea, actually, what is the system of equations behind that tool, and you also do not know how the solver works inside, actually. So, and in this sense, this is always a black box. Dynamic simulation. What kind of problems it allows to address? Dynamic simulation allows you to describe your supply chain with all the details and taking into account randomness, time, logic, processes, and so on. And this way, it allows you actually to understand how your supply chain works. And solely to manage your supply chain effectively and efficiently, you have to understand how it works, because otherwise, how you can manage that? Having just the high-level understanding of that, it's not enough now to be competitive. Then, let's say you used analytical approach to find the configuration of the supply chain. Then, how to be sure that this configuration makes sense, it will work? So, how to check its feasibility? Because in analytical world, we use things like throughput, but in the real world, we have a capacity. And again, the difference between the capacity and throughput, you see the capacity is like you have a black box and you know how many iPhones you can put there. Throughput means you have like a pipe and you just throw the iPhones and you have no idea how many of them can be there. You could just throw them there and you know that you throw, let's say, 100 iPhones per minute. So this is all you know. This is the parameters you operate with when you do analytical model. Then let's say again, you just created analytical model, get the result, what's the plan? You just have the answer, what's the plan? But then the question is how to map this plan to the reality. What you have to do in the real supply chain to fulfill the plan. So how to implement that. And another important implication, this is the supply chain improvements. Let's say you already have a supply chain. You do not plan to open or close new facilities. You just want to know what else you could do with this supply chain to make it better, to make it more efficient and effective. So you have some assumptions, and the dynamic simulation is the only way to test those assumptions and decide which way to go. Again, if you try to generalize that, dynamic simulation helps you to answer the question how to reach operational excellence in your supply chain. But again, what we should remember about dynamic simulation, I know that the most of you from that world, and that's probably too obvious for you, but anyway, yeah, dynamic simulation allows you to take into account all the specifics of the supply chain, logic, processes, resources, and so on. But at the same time, simulation-based optimization is fundamentally different to the analytical one. Because when we describe analytical model and solve it, this is the best result we get, right? So when we do simulation-based optimization, optimization engine is always external part to the simulation model. And it treats simulation model like a black box. Optimization engine just measure the output, generating other input parameters. And so in this sense, it's less efficient than analytical one, right? Also, what is important to remember, you have to be very careful deciding on the abstraction level, on the level of details which you use to model the supply chain, because of too many details may result in slower performance. If you try to map those analytical methods and dynamic simulation methods to the pyramid of supply chain design and analysis problems, we will get the picture like that. So again, analytical methods, they're used at the top of this pyramid, and then and at the bottom of the pyramid, you use the dynamic simulation to solve the problems. Obviously, there is like a border in this abstraction level when you cross this border, there is no way to represent these details you want to take into account in analytical world, and then you have to use dynamic simulation modeling to solve those problems. Another interesting thing, if you look at the number of opportunities for innovations, that will have exactly the same shape as the pyramid of supply chain design and analysis problems. Because of, again, the more details you take into account, the more problems you may solve. Now about AnyLogistix. Well, as you already guessed, AnyLogistix is a multi-method supply chain optimization software which has both technologies inside, analytical modeling, as well as dynamic simulation one. The dynamic simulation model is extendable with AnyLogic Professional. This way you may model any kind of logic you may want in AnyLogistix. And also AnyLogistix provides you a powerful visualization dashboard, visualization capabilities, as well as dashboard, which allows you to see how your supply chain works, how it operates in time. And again, if we just come back to this pyramid and try to map the tools which are available on the market for tools for the supply chain design and analysis, we'll get the following picture. So 99% of the tools used only analytical optimization, and that's just quite easy explainable. So actually the main part in this analytical optimization is engine. And what those tools does, do. They just develop the front end to create the model which is solved with those solvers. And AnyLogistix works on all those abstraction levels. So you may do inside for wall modeling, you may work at the network level and describe these network level logic processes and resources. And also you can use analytical methods to solve your problems. AnyLogistix key differentiators. So AnyLogistix integrates analytical and dynamic simulation methods in one package. So this way, it allows you to do more precise analysis of your supply chains. So it allows you to do inside for walls modeling. So you can model, again, how your factory influences your supply chain, how your production scheduling can influence your supply chain, how your warehouse logic and processes influence your warehouse. It's extendable with AnyLogic. So again, any component of the supply chain, any rules, I mean, how those components communicate to each other may be extended with AnyLogic Professional. And that's, by the way, what we are going to show you during the workshop, how to do that. Then visualization, I already told about that. And the last but not the least, thanks to dynamic simulation, you may measure almost everything in your supply chain. That's not only cost like in analytical models. You may measure like the service level, you may measure bullwhip effects, capacity, and not only for the like a whole supply chain, it can be measured for the particular object of your supply chain. You may measure utilization, for example, of the components. You may measure how your transportation works, and so on and so on. Much more things becomes measurable once you start use dynamic simulation. So I'm close to the demonstration. Now, a bit about history. It's not as long as AnyLogic one. We just ran first version in last year in June, and it has like a basic functionality which is suitable for the implementation, but certainly there were a lot of things to do still with the product. In November, we added functionality which allows to do extensions for AnyLogic, but to AnyLogistix, but honestly, it was very complex to do. So in 2016, in April, we released ALX2, which actually has already, which had a lot of new features, including new graphical interface, new experiments. The simulation model was much more powerful than before. And the next release is scheduled for January next year. And one of the main features there is Simplex. So now network optimization in AnyLogistix is powered by Simplex. And in this sense, there is no much difference with any other analytical supply chain optimization package. So also we are adding a lot of other features to the product. Please don't be don't be confused that the version is increased by 0.5 because with each release we actually almost double the functionality, and actually if you just increase it by 0.21, it would not represent the number of changes we are doing in AnyLogistix. So, Anatoly, now a demonstration of the product, and then we will tell you about our plans for the next year.
Okay, as Timothy said, we have a lot of improvements and new features in AnyLogistix, but I want to focus today on changes in experiments that we have. And I would like to start with greenfield analysis experiment. I'm sure all of you pretty well know what it is. So if you have a number of clients, for example, in your region, and you do not have an idea where to have your warehouses, this experiment helps you to understand, to get an insight, at least where they could be and how many of them you need. So running the experiment, you get a picture like that. So you get locations for new warehouses and connections between warehouses and your clients. But what if you need a regional warehouse to serve this, or regional distribution center to serve these warehouses? You can use greenfield analysis again, and you just choose corresponding group of destinations and run the experiment. And then you see you get a next level or next echelon of your supply chain. And you can go further and further from the like city level to region level and then country and worldwide. Another good news is that we were able to improve performance of greenfield analysis experiment by 30 times on large-scale problems, and the scale of problems was increased by 4 times as well. So now I'll switch or select a project related to network optimization. So our network optimization experiment was completely rebuilt, and we have a new way to define network optimization problem. Now the important concept is constraints, so you can have constraints for storages or for flows. And moreover, you can have like composite constraints that limit number of flows simultaneously or number of storages. For example, you can limit total supply capacity of a supplier within some period. So in this scenario, we have 3 suppliers. 2 of them are limited by capacity, these on the top, and the third one is not limited, but it's much more expensive. So let's run a network optimization experiment and take a look what we get. So Ciplex engine proposes number of best solutions, and we see that it doesn't propose to use the expensive supplier. Actually, in this model, we also have periods. So period is another important concept, and it allows you to not only optimize network structure, but also to do a master planning or master scheduling. So in this model, we have 4 periods representing quarters of the year, and all the constraints, all the flows and demand are specified within periods for each period independently. In this model, we have 4 periods, and demand is increasing in time. So what happens here? The sites or distribution or warehouses start to accumulate inventory to serve their customers in later periods. But what if we make our supplier a little bit cheaper? Well, probably not a little bit. Let's make it 2 times cheaper and run experiment again. We see that, first of all, it proposes other warehouses as the best solution. And moreover, it assumes that we should use that expensive supplier. It's still much more expensive than the others, but it became less expensive than the storage cost associated to inventory handling on warehouses. So in general, network optimization experiment allows you to define a lot of combined constraints so that you really can handle all the constraints you really have in your supply chain. And now with Cplex, AnyLogistix is capable of doing any analytical optimizations that you can do in other analytical tools. Well, let's go to simulation. We have a lot of requests from our partners and clients while we develop AnyLogistix, so we respond on that and we add new functionality in the product. And one of these functionalities is milk runs. So I ran the simulation experiment, and you may notice that this distribution center ships not directly to customers, but it accumulates orders to ship several customers at a time. So one vehicle goes to first customer, then second, then third, and if there is order for the fourth customer, it will go there as well. And of course, such behavior can and should influence the whole supply chain behavior. So I will run comparison experiment, which is also new compared to previous version. And you may not surprisingly notice that the milk runs approach is cheaper in terms of transportation costs. The travel distance is lower as well, which is important for vehicles maintenance and so on. And even service level becomes higher, but that can really depend, because the longer milk run you have, the more your customer have to wait. The end customer in this milk run have to wait for the goods. So it can really depend, and using this tool, you can find a trade-off between costs and service level. By the way, you can notice statistics associated to gates. It's another new feature in model internals. So there are loading and unloading gates, and sometimes, in case of heavy usage, they might be a bottleneck as well. Well, the extensibility of AnyLogistix. Actually, every supply chain object in AnyLogistix simulation experiment is AnyLogic agent. And what probably some of you saw what it was in previous version, but now it's described by means of flowchart, and that really eases an ability to extend or replace existing standard logic with your own. For example, this is the standard warehouse or distribution center in AnyLogistix, and it has 4 main processes: the incoming orders processing, incoming and outgoing shipments, and inventory replenishment process. I said that it is easy to extend such object with your own logic. And actually, in this particular scenario, we have an extended factory which has several production lines. And each line can be used as a resource for different production processes of different resources. It is customizable from AnyLogistix user interface. We have two tables here, and one stands for number of lines we have, and another one defines sequence of production processes. So, of course, the insightful logic can influence the whole supply chain, and let me demonstrate it to you. I will decrease number of production lanes of certain type, and you will see that service level of the entire supply chain starts to go down. And again, if we increase number of resources again, it will help us to make service level higher. By the way, you can have any number of extended objects with their own logic, or probably all of the objects could be your custom ones. For example, in this scenario, we have another extended object, which is distribution center. And it just has some additional resources required for loading and unloading vehicles. If you take a look on internals, there are only two small pieces of original standard model which were rebuilt to achieve that functionality. So extending AnyLogistix became much easier than it was before, and can be done easily by anyone who's familiar with AnyLogic. By the way, the logic is not the only thing you can extend. You can also add your own statistics, your own KPIs. For example, here you can see statistics related to the staff utilization in that extended DC that I just shown. So it is propagated on top from AnyLogic model to AnyLogistix user interface, so that you can work with that on a dashboard. Another important feature is custom experiment, which can be used for almost everything you could think of in terms of manipulating the scenario or experiments. So you can populate it from external data source, or, for example, your IT infrastructure. Then you can perform sequence of existing experiments on it and get results back, and probably upload them somewhere else. So that's it. And if we open the AnyLogic, that's how it looked like. Here is exactly the extension that allowed us to add customizable production lines and to define sequence of steps in AnyLogistix. So it's not a large part.
Okay.
Okay.
Thank you. Well, what is next? As I already said, we are going to release ALX 2.5 in January next year. Then in February, we are going to release AnyLogistix Personal Learning Edition. And ALX 3, we are going to release in autumn next year. And yeah, this is just some of the features we are going to add. So first of all, we are going to change user interface for our product because of, well, Eclipse, what provides Eclipse to AnyLogistix isn't enough to get the kind of behavior from the user interface we actually want to have. That's why we want to switch to another platform. Also, what the feature which is often requested by the customer, this is a client-server application because of most of the customers want to run simulation as well as analytical optimization on their servers to make it faster. Also, there are a lot of requests for the data validation. So in order, AnyLogistix could validate the data you enter into the system and suggest what you have to change there, what is wrong there, let's say, to run the simulation or analytical optimization experiment. So basically, we are adding functionality with a very good speed. As I said, we almost double the functionality with every release, and we promise you we'll keep the same. We'll keep doing the same the next year and so on and so on. So, AnyLogistix workshop. It's at 3 p.m. This is the program. So what we are going to show you, we'll show you this multi-echelon greenfield analysis, which is actually pretty similar to what were available in the previous version. So, and this is just a small exercise. But then what we are going to do, we are going to show you how to do network optimization with Simplex and how to extend AnyLogistix with AnyLogic. So you are welcome to participate in the workshop. So thank you very much, and yeah, hope to see you all next time on the next conference. Thank you.
Is there an interface to the Simplex solver that lets you do other kinds of problems other than the network solutions and the greenfield ones that you talked about? So if I have some other problem within my facility or something that I want to look at an optimization, can I build that and link it in?
This is a good question. So according to our license agreement with IBM, we actually can't open you the Simplex API, underlying Simplex API. But on another hand, that we were thinking that we could just provide some kind of flexibility, allowing you to just customize this optimization problem in a way and still use the Simplex. So again, we're just thinking about that. Yeah, there are such requests to customize our model in a way and still use Simplex inside. So, and this is actually not probably the question of calling Simplex API, and more the question about the customization of the model which is generated by AnyLogistix.
On your ability to fleet size, do you use any type of resource optimization type of engine to understand an ability to multi-trip vehicles or to shift basically vehicle start and end times to minimize resources?
Not sure I understand the question. So you are talking about the own fleet, if you have like
So there's a fleet estimation output relative to the AnyLogistix software.
Oh.
Within that output of the fleet estimation, is it looking at resource optimization, meaning shifting around when trucks can start and end, or looking at multi-tripping types of vehicles, meaning that a truck can run on multiple routes to be able to minimize those resources?
Mm-hmm. So, do you want to?
Yeah, well, by default, AnyLogistix treats vehicles as resources which are just 24 hours available, unless they're currently shipping something elsewhere. But again, this logic of internal vehicle resource can be extended to follow shifts and probably different constraints where it could go or where it could not go, probably match drivers and so on.
Driver schedule.
Okay.
Yeah.
Okay.
Okay, thank you.
Thank you.
Thank you.